Hi and welcome back. This is Pankaj here. In the last video, we have gone through many questions on permutations, isn't it? We did go through the questions based on the alphabets, right? We had looked at when alphabets are going to be together, when they're going to be separate, and how exactly to work with them, right? Those are the kind of questions that we have gone through in permutations. And we also derived a formula for NPR, correct? What we're going to do right now is to look at a few questions where we will understand how to work with numbers, okay? The digits that's been given to me, and how do I form the number of digits, and what are the different types of questions that we're going to get from that, okay? Let's look at that. I'm going to pick up a question from the textbook directly. Okay, the question says this: how many four-digit even integers? So first of all, let me just take this down. Okay, so 4-digit even integers. Okay, can be formed using the digits 0, 1, 2, 3, 4, and 5. Okay, let's see how to do this. See, many questions here might not be in your textbook, might not be in NCERT, or might not be in R.D. Sharma or R.S. Agarwal or the ISC textbook. But if you practice these questions, it'll give you an idea as to how you can work with the other questions which is there in the textbook. Okay, so you can apply the same thought process and you should be able to solve it. Now, let's see, I'm supposed to be forming a 4-digit even number, which means that I'm filling up 4 boxes: units, tens, hundreds, and thousands, correct? Now, if it is supposed to be an even integer, then the units place can be filled with a 0 or a 2 or a 4, isn't it? The units place is 0, 2, or a 4, then I can consider this to be an even number. Okay, so what about the tens place? So the tens place can have anything, right? That's not a problem. And 100 place can have anything. But what about the thousands place? The thousands place cannot have a 0 in it. Getting me? Because if I put a 0 here, it becomes a 3-digit number, right? So those are my options, which means that I have 3 options for the thousands place, 3 options for the units place, and what about the remaining 2, hundreds and thousands? Okay, I can fill up any one of the 6 numbers, so this can be done in 6 different ways and 6 different ways. Okay, so how many 4-digit even integers can I have? It's going to be, let's see. For the thousands place I can have 5, not a 3, because I'm not using a 0, but I can use all the other ones. So it's 5 into 6 into 6 into 3, and that's going to give me 30 into 18, and that's going to be how much? 540. Most of these questions are very simple. The number question seems to be very, very simple here. How many 2-digit numbers can be formed using the digits 8, 1, 3, 5, and 4? Okay, now 2 conditions: repeats are allowed or repetitions are allowed, and there are no repeats. Let's see how. So if I'm forming a 2-digit number, then I'm going to be filling up 2 boxes. So the first box can be filled up in 1, 2, 3, 4, 5 different ways. Okay, because I can repeat, so this again can be filled up in 5 different ways, which is 5 to the power of 2, which is 25 digits that I can form. If there are no repeats, what happens? I can fill this up in 5 different ways, and this can be filled up in 4 different ways because one of the numbers has been used up in this case, and that's a 20. This is a very simple question here. It says how many 9-digit numbers can be formed of different digits, which means there is no repeats. Okay, so how many 9-digit numbers can I form? Let's see. If I'm supposed to make a 9-digit number, I'm going to fill up 9 boxes: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, how many digits do I have from 0, 1, 2 till 9, isn't it? I cannot fill up a 0 here, because if I fill up a 0, it will become an 8-digit number, and hence this will have 9 options. Correct? Now, out of the 10 digits that I have here, I have already used up one of them. I have filled up one of them here, which means I will have remaining 9 digits. And that 9 digits can be filled up, any one of them can be filled up here out of the 9. So this box has 9 different ways. And the box after that will have 8, 7, 6, 5, 4, 3, 2. Okay? So that is the number of ways in which I can make a 9-digit number. Okay? And how much is that going to be? Let's see. 9 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 will be 3265920. That's 32,65,920. All right, I don't see any interesting question on numbers. I'm just checking the book. Okay, this looks to be a bit interesting. How many numbers are there between 100 to 1000? How many numbers are there between 100 and 1000 such that every digit is either a 2 or a 9? Okay, so every digit has to be a 2 or a 9, which means I can have 222, 999, 292. So the numbers are going to be a combination of 2 and 9. And how many numbers are there going to be between 100 and 1000? Well, after 100, whatever numbers that I get will be a 3-digit number. It'll all be a 3-digit number until 999, because after that it's going to become a 4-digit number, isn't it? So basically he's asking me how many 3-digit numbers between 190, 100 and 109, 199 are there, which has only 2 and 9. Very simple to fill this up. And I'm allowed to repeat, which means this box can be filled up in either 2 or a 9, so 2 different ways. 2 or a 9, 2 different ways. 2 or a 9, 2 different ways. 2 to the power of 3, which is 8. Very simple. All right, I don't see any more questions which are challenging in permutation. Especially the number questions. So I'm going to stop doing number questions here, just in case I come across a number question which I feel is a bit challenging, or if you feel that needs to be solved, please go ahead and post it on the comment section. What I'm going to do is to pick up the next section, that is permutation of like things. What am I talking about? We have looked at questions like a pencil. Okay. Now, what are the different ways of arranging these words taken all at the time? 1, 2, 3, 4, 5, 6. So it's a 6 factorial, isn't it? That's what we said. Now, what about a word, something like memo? Here, I'm, calling this as M1 and calling this as M2. Why? Because, if in case I'm writing M1E M2O and then M2E M1O, they both mean the same. They're not different, isn't it? So likewise, for every permutation that I'm going to do, I will have these kind of situations appearing. For example, I can write EM1 M2O, which is equivalent to EM2 M1O. So all these options has to be removed when I'm doing the permutation, isn't it? Okay, let's see how to do that. Okay, now let's say there's a word in which there are n objects. Okay, be it a word or anything at all. Let's simply say there are n objects, and among these n objects there are p things which are same or alike, and another set of q things that are alike. Okay, and I'm also putting a condition that p plus q is equal to n, which basically means that there are no other elements. There's only p's and there's only q's. Okay, so let's say, I mean, I have n things here, right? So, or n objects here. The permutation of n objects is n factorial. Very simple. Okay. So, let's say that there are x ways of permuting this, or the permutation is simply x. But p things can be permuted among themselves in p factorial ways. And q things can be permuted amongst themselves in q factorial ways. That's what we did, isn't it? For example, when we had the situation when we had to take P-E-N-C-I-L, and then we had two words to be together. What did we do? We took this as an x, and then we said P 1, 2, 3, 4 factorial, 1, 2, 3, 4, 5 factorial, into 2 factorial, which is E and N, which can be permuted amongst themselves. So that's exactly what I'm doing here. So p things can be permuted amongst themselves in p factorial ways, and q things can be permuted in q factorial ways. Well, this is nothing but the permutation of n objects, which is n factorial. So what is x? X is the number of ways where p and q things together can be permuted, can be written as n factorial divided by p factorial into q factorial. Okay, so what does it basically mean? It basically means that if I have to take care of permutation of the word Mississippi, which is M-I-S-S-I-S-S-I-P-P-I, okay? Now, when I'm taking care of permutation of this, I'll have to count the number of repetitions also. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So that's 11 factorial, but divided by how many times is m repeating? None. Okay, just one of them. How many times is I repeating? 1, 2, 3, 4. 4 factorial. Into how many times is s repeating? 1, 2, 3, 4. That's again a 4 factorial. Into, and is is over, and how many times is p repeating? 2 factorial. This is the total possible ways of permuting it, or the total possible words that I can get with Mississippi. Okay. Now this situation did not arise earlier. We never looked at this kind of a situation. We always took the words like combine, and then pencil, daughter, and beat, any other word wherein the words are not repeated. Okay. So we did not come across this. This is the first time we are actually combining, coming across this kind of a situation, right? So that's the permutation of alike things. Okay, that's very simple. Let's directly look at a few questions here. How many ways of permuting the word India? Very easy. There are like 1, 2, 3, 4, 5 factorial divided by, well, I is repeating twice, so 2 factorial. How about mathematics? Mathematics. Okay. How many words are there? How many alphabets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 factorial divided by, how many times is m repeating? 1, 2, 2 factorial, into how many times is a repeating? A 1, 2 into 2 factorial. And is t repeating anytime? Yes, t is repeating twice. Into 2 factorial. Into, is h repeating? No. E repeating? No. I repeating? No. C and S? No, not repeating. So that's it. That's the end of it. And that is my permutation. Okay. Number of possible options. Well, you can use a calculator to find the value here. I'm just trying to explain the concept behind it. Let's look at another word. Allahabad. Allahabad. Well, you have come across this question. It is there in NCRE 2. So let's find out how many words are there here, how many letters are there, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial divided by, how many times is A repeating? 1, 2, 3, 4. 4 factorial into, how many times is L repeating? 1 and 2. 2 factorial. Is H repeating? No. B repeating? No. D repeating? No. That's your answer. What about the word commission? C-O-M-M-I-S-S-I-O-N. Okay? S-S-I-O-N. So how many words are there? How many alphabets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial divided by M, S, I, and then O. Okay. So how many times is M repeating? 2 factorial times. Oh, 2 times, so that's 2 factorial. And I is repeating 2 factorial. O is repeating 2 factorial. So that's going to be a 2 factorial again. And that's going to be the solution. Very simple. Okay. Let's now move on to circular permutation. A very good explanation has been provided here for circular permutation in the ISC textbook. I'm going to explain the same thing to you. Let's say I have 5 letters A, B, C, D, and E. Okay, and I'm supposed to be arranging them or placing them in a circle. So something like this: A, B, C, D, and E. So now they are in a circle, right? They're sitting around in a circle. So what are the possible ways of arranging them? That's a question. Okay. So in this, you need to understand one thing, that if I arrange it like this, in a linear way, in a straight line, then A, B, C, D, E, if they are in a straight line, not in a circle, if they are sitting in a straight line, then A, B, C, D, E will be different than B, C, D, E, A. And that will again be different to D, C, D, E, A, B. You getting me? And likewise, I'll have D, E, A, B, C, and then E, A, B, C, D. And then the next one will be A, B, C, D, E, which is going to be this. So ideally, I have 5 linear combinations. But I'm actually thinking about this. If I'm making them to sit in a circle, all these are the same. See, A, B, C, D, E, that's one of them. And then I can start with a B. It's the same circular permutation. It's again C. It's the same thing, right? So when I have 5 different people sitting around a table, all these permutations are the same. It's not different. Okay? So what I'm going to do is, I'm going to fix one of the person. Let's say A. I'm going to fix this person and permute the remaining letters or the remaining alphabets here. I'm going to permute only these people. And that will give me the circular permutation. Basically, I'm fixing this person and then asking these people to shift their places. You getting me? So if I'm doing that, I'll get the circular permutation, which is simply 4 factorial in this case, which is nothing but 5 minus 1 factorial. Okay. So if I say that there are X permutations, okay, then each linear combination here, one linear combination will generate 5 different options. So if there is one linear combination that I have picked up, then it will have 5 different combinations associated to that, which is going to be equal to basically the permutation of 5 objects, which is 5 factorial. So X, which is my original value, is going to be 5 factorial divided by 5, which is 4 factorial. What we need to remember is this. If it is a circular permutation of n objects, if I'm doing a circular permutation of n objects, then the number of ways it can be permuted is n minus 1 factorial ways. That's it. Okay. Now, this is a very important section and very interesting too. I'm going to pick up more questions from here and try doing them for you. 20 persons were invited for a party, so there are altogether 20 people, and invited for a party. In how many ways can they and the host? So there is a host also, which means there is altogether 21 persons. They need to be seated around a round table, okay, circular table, in how many ways will two particular persons be seated on either side of the host? We'll come to that later. First of all, we will try to understand how many permutations are there in this case. So I have 21 people to arrange, so it's simply 20 factorial, which is 20 minus 1 factorial. That's 20 factorial ways of arranging 21 people around a table. Okay, now let's say this is the host. This is the host sitting over here. So I've been told that in how many of these ways will two particular persons be seated on either side of the host, which means let's take out of these 20 people, let's say A and B, they always sit next to him. Okay, so what have I done here? I have taken 2 out of 20 and I've placed them right next to the host. So I'm now going to consider all these 3 to be one entity. So the host and 2 people are one entity, which means I have now, instead of 21 minus 3, which is 18 people to be arranged. Correct? Now, if I have to arrange 18 people, along with that I have this entity, so that's almost altogether 19 people to be arranged, which is simply 18 factorial ways of arranging them. But the host and the neighbors of the host can be a AB or a BA, isn't it? I mean, A can be seated here and B can be seated here, or B can be seated here and A can be seated there. So it can be a B host A situation also. So that's a 2 factorial. So that's the total number of permutations that I can have. So what I'm going to do is I'm going to stop the video here. There are more questions that I can pick up, which I'll be doing in the next few videos coming up. I would appreciate again if you can subscribe to these videos and suggest these videos to your friends and share it with your friends. And any improvement or any suggestions, be frank and put it down to the comments column. I will try to improve upon that. Okay, thank you very much and best of luck.